what I am going to say here is about the page of the ITRF. And once upon a time, when I visited China, I had that dream that Dr. GGOS will alleviate my pains. But it is not that simple, and you will see why in a second, but I am waiting for the next slide. So this is our heritage from ITRF 2008, collocations of the other techniques via GPS or GNSS. You can see, and I want you to answer that question, which couple, GPS and others, is the best geometry. Here we have the LBI network, we have 41 sites, and you can see that it is getting better and better, and I am happy to see that, but there are also other problems, because we have only 26 sites which are usable, but we have to thank Australia, New Zealand, and others because they are installing new generation system. But in the same time, we have to look to the observation because we have the availability. Here you have the availability of observation per station vertically. Horizontally you have the time, but this ideally should be a black rectangle, but it is not the case because we have bad boys and good boys. This is the network for SLR. As you see, we have 32 sites, but it is not that good. It is poor. You can say that. The ILRS will not be upset about it. And in fact, we have only 19 sites which are usable, and there are still sites where we need collocation with GPS. So there is some action to do. And in terms of observation availability, we still see that black rectangle that we want to see, big holes, white holes, and of course we have very good sites, but still we need to fill that rectangle, and I am waiting for GGOS to do that. This is the current collocations. You have all the network here in terms of collocation between GPS and other techniques, and as you see, GPS Doris is the best geometry that we can see. It's a shame for SLR and BLBI. More than 600 sites were observed and analyzed by IGS. Focus in the green dots. We have about 400 sites with large history between 10 to 18 years. But we have problems, even with GPS, of course. These are the sites where we have discontinuities. 50% of the sites have discontinuities. This is a major issue for GPS, and in particular for the reference frame. And this is, for instance, the rectangle that I would like to see as black rectangle, but with spots which are in red, which are the discontinuities. It's harmful for the IGS reference frame. The thorn issue, the local tie accuracy. We cannot say that the accuracy of the local type could be better than 3 millimeters. If you don't agree with that, please let me know why. And actually there are discrepancies, but we need to improve the ties. You have to be French to understand these slides. I am not kidding, we have to improve that. And because IGS, GPS is playing the link between the other three techniques, but if GNSS has error, and it has error, as uncalibrated radon, and we have 50% of the discrepancy larger than 6 millimeters. But these discrepancies are not due to local ties, not entirely. We have discrepancy otherwise. We gain precisions. We are happy as time goes. But what about accuracy? We still need to improve the ITRF by a factor of 10. As you see, we gain accuracy, but precision, but not accuracy. So what should we do and should not do? We need money, of course, to secure the ITRF infrastructure. We have to avoid bureaucracy. But I am a GGOS warrior in the background, even if I am not a member of GGOS, because GGOS idea is a noble idea. But if it is combined gravity and geometry, I am not a fan of GGOS, because nobody complains about such things. But many are complaining about the ITRF accuracy. So leave science and to the IGA services and the scientists. The Bureau of Network and Communication is useful, helpful. That of convention is wasteful. explore maybe interaction with TIAG and GGIN, and yes, we can.